Hi everyone, welcome to the NOAA Central Library. We're very excited to have the NOAA Innovator Series continue with the Technology Transfer Office. And I'm going to turn it over to Derek Parks to introduce our talk today.
Thank you so much. So again, this is Derek Parks, and thank you very much for attending our Innovators Brown Bag series here through the NOAA Library. Today we're doing something a little bit different. In the past we've focused on actually NOAA inventions and innovations. Today we're going to give you a little bit more information about some of the, or one of the technologies that we've funded through NOAA and specifically through the Small Business Innovation Research Program. So give you a little bit different flavor of some NOAA innovations. And to introduce our speaker, I'm going to pass it over to Vince Garcia, who is the manager for the SBIR Small Business Innovation Research Program here at NOAA. So Vince, take it away.
Thanks, Derek. Hey, everybody. Again, this is Vince. I'm going to do a quick quick overview of the SBIR program. I might as well plug in and give you guys some information since the audience is both internal and external. The SBIR program is a federal program that provides federal funding to small business to provide agencies with innovative solutions. Specifically here at NOAA, we provide about $120K for phase ones awardees, and then for phase two, $400K. From a schedule perspective, we put out an announcement once a year, usually around October. We are administering these through grants announcements. So go to grants.gov this coming October or November for that to be released. Topic areas, examples of them from this past year. For this fiscal year 19, it's already completed. For 20, again, it'll be out in October or November. Did I drop off? Okay. So the type of topic areas we're looking for, and these are just examples, are things in aquaculture, recreational commercial fisheries, big data, next generation NOAA platforms, and things of that nature. I want to talk a little bit about I talked about the phase one and the phase two for potential applicants, but specifically for the NOAA folks that are on this call, what does that mean for you as a phase three? One of the things that we want to make sure that you guys are aware of is that if a company, such as the company that will be focused here today, if a company has gone through a phase one or a phase two with NOAA and or other agencies, they are qualified for a direct award or sole source award from us. That means that if we can provide justification that the technology that they've done through SBIR is in the same, is from the same technology, same lineage as for what they've done in the SBIR. And if we want to buy that product or do further R&D, they are qualified for a direct award phase three. More information, if you want to talk about, for the NOAA folks, details about how to acquire a phase three, you can contact me, vincent.garcia@noaa.gov. So with that all out of the way, I'm going to introduce our speaker for today. Her name is Colleen Keller. Colleen Keller is an operations research analyst with expertise in U.S. Navy systems, tactics, and procedures. She is also Metron spokesperson for the application of Bayesian analysis to search and rescue operation. Ms. Keller wrote the winning SBIR proposal for this app based on another app she conceived and developed to support search and rescue operations. She is a private pilot, an aircraft owner, mechanic, and air races and flies aerobatics as hobbies. Ladies and gentlemen, Colleen Keller. Floor is
hi,
yours.
Thank you. Thank you, Vince, and thank you everybody for attending this webinar. We really welcome the opportunity to tell the NOAA-wide audience more about the work we've been doing on this phase two app. This app we're calling Red Sky, and it's an app that attempts to crowdsource weather for coastal mariners or people operating in the littorals where weather is difficult to forecast and predict. And as a pilot, I kind of see this as a parallel to pilot reports for pilots, which we always find extremely valuable because it tells you what the weather is like now in your area, vice what we think it might be like down the road. So with that, I'll launch into my slides. I was told it would be it would be a good idea to give you a little introduction to Metron, since I know that Metron has very little exposure within NOAA. We are primarily a DoD contractor consultant, working mostly with the Navy, but also with some of the other agencies whose medallions are shown at the bottom. We're an employee-owned small business, and we have a strong culture of working from first principles in mathematics, physics, engineering, and computer sciences. We were established in 1982, and we currently do about $60 million of business a year, growing steadily. We have about 156 employees spread around the country, mostly in Washington, D.C. and San Diego, with an office in Portland, Oregon. And we have field representatives working at Navy and Marine Corps sites, like side by side, sort of like staff scientists at Commander of Pacific Fleet in Hawaii, the Naval Warfare Development Center, MCCITIC, which is a Marine Corps office in Quantico, and at OpNav offices in the Pentagon. Our staff typically has is academically very strong and has a lot of experience. We're very proud of the fact that many of us hold advanced degrees and PhDs. And many of us have a greater than 10 years experience. I personally have been doing this since the 80s, working with the Navy, and I've been at Metron for over 20 years, joining in 1995. And Metron typically has established these long-term relationships with key clients, which include the Office of Naval Research, DARPA, and SBIR, which is why I am in San Diego, because of the presence of SBIR here. Just one slide on what we do. We do a whole bunch of stuff, but it's typically first principles mathematics and engineering. We started doing submarine work and underwater acoustic work, doing search detection, data fusion, and tracking. We moved into big data applications, anomaly detection, looking at lots of data and picking out unusual activity, with applications to a whole variety of things. Optimization, linear programming, and resource allocation. The signal processing and physics-based modeling, again, a lot for underwater detection. And then on the right, the campaign modeling and simulation and analysis is what I've been primarily working in here in San Diego over my career. We build a lot of software and tactical decision aids. And lately, Metron's been getting into the business of building prototypes for unmanned underwater vehicles and developing autonomy algorithms, which is quite interesting work. The mobile web application development is a recent development for us. It's something that I started with the search and rescue work that I did about 10 years ago, and we continue to find different ways to build apps to kind of bring our science to the table for the common person. And then the Bayesian search theory is something that Metron has done for quite a while, with some pretty sensational searches that we've been part of. And I've had the privilege of doing that work as well. It doesn't pay a lot of money, but it sure makes life interesting sometimes. So Vince talked about the SBIR program, so I really don't need to hit most of my bullets here. I don't want to steal Vince's thunder. But it's basically a program that NOAA pays into, and then in return, NOAA gets to fund or have funded projects that are of interest to them. And the topics for these projects come from within NOAA. So people write these topics, and then companies like Metron bid against them and develop technologies and hopefully make them very successful. And then NOAA benefits from them, and the company benefits from them, because the company gets to commercialize and potentially make money from these things, and it stimulates innovation and discovery and all those good things. So it's kind of a win-win program for everybody. And Metron has been participating in the SBIR program since its inception. And I have a bullet down at the bottom, says since between 2000 and 2016, we've won 73 phase ones and 37 phase twos for a total of $33 million in revenue. And we are one of the big SBIR success stories where we took one of those SBIRs, which was the building of the Naval Simulation System Warfare Analysis Model, which I've done a lot of work with. It became a phase 3 success story, started in the 1990s and is still going strong and licensed out and used by many organizations within the Navy, and has generated over $90 million of business for the company. So the SBIR program is quite important to companies like Metron, and we continue to participate in them and find them very helpful in developing new expertise. So the topic that leads me to what we're going to talk about today, which is a topic that was first put out in 2017. It asked for the person writing the proposal to propose a smartphone app for marine weather observations. And it basically cited that the technology that we have now in smartphones makes it possible to report geolocated and time-stamped information along with pictures, and then to put that directly out on social media or into databases in a real time, as long as cell phone connectivity exists. The 3 purposes for collecting this data are listed in the SBIR. They would increase the situational awareness of forecasters who are responsible for predicting weather in the coastal and inland water zones. And that was the #1 reason why the TPOC, the technical point of contact, who was a forecaster in Seattle for the National Weather Service, that's why he wrote this SBIR, because he felt that he needed feedback for his forecasts. And he was using Twitter on a very informal basis to watch and see how well he did, kind of like Monday morning quarterbacking, you know, I came pretty close this time, you know, he's keeping score. So he wanted something more formal for doing that, and he conceived of this topic and this app for that purpose. In addition, there's an obvious public safety benefit from developing this app. If people have access to these reports in real time, just like pilots have pilot reports, then they can be more safe, and they can, you know what the weather conditions are around them, and they can make no-go decisions if they don't want to go out that day. And then finally, this data isn't just perishable. We're putting it into a database, and that database provides a historical record which could potentially provide feedback to NOAA forecasters and modelers on their models. They can vet their models against that data. So those are the 3 purposes for the SBIR. We won the phase 1 in 2017. We did a 6-month effort that produced a prototype by December. We were awarded the phase 2 in 2018, a couple months later. It's a 3-year effort. We've accelerated our work to try to get something to market early. We have a beta version of the app right now, which is going to be hitting the app stores in May, so next month. And our TPOC continues to be the Seattle NOAA NWS forecast crowd. So it was Jay Albrecht, and Jay is transitioning it to Logan Johnson as Jay is retiring. The new app, the app was called MAR app, for Maritime Reporting App, but we decided we needed to get sexy with the marketing because it's going to market. So we gave it a lot of thought, and we're calling it Red Sky, after the Red Sky at Night. What is it? It's the saying, Red Sky at Night. So the concept behind Red Sky is that weather in the maritime coastal area is fast changing and difficult to predict, and we wanted to give NOAA forecasters feedback in these areas so they can vet their predictions, and we wanted to keep mariners safe for boating operations in those areas. So what we're doing with Red Sky is crowdsourcing these weather conditions by using cell phones, which everybody has. It's kind of like having their own little weather reporting mechanism right in the palm of their hands. And we all know how people love to share their experiences. And so we're trying to spin this as a fun way to kind of social media the weather. And in the process, we get the data that we want. And we're calling it, some people have called it Waze for the ocean. I'm not a Waze user, but I understand the concept, and it goes along those same principles. So here's just a little cartoon of how it works. The cell phone, which we call the mobile client, is what the reports are being generated from. It uses GPS input and other inputs from the cell phone's sensors and other weather stations connected to the phone. I'll talk with that in a moment. It reports across the cell network to the internet, and then from there into our database, our server database, which is a repository for the data. The reports, if you don't have cell coverage because you're too far off the coast or you're not within a cell tower, the reports are cached on the client. And then as soon as you get back to cell connectivity, the reports get automatically sent out. That's a given. Back on the server, we give access to Twitter, so reports can be put out over Twitter, and then NOAA has access to the database via an API. So there's no web presence for Red Sky. We figured everything would be done straight over the cell phone, but the data can be accessed out of the server. So a note about sources. One of the key things about this is that we wanted to make the data as quantitative as possible. So we're leveraging the sensors within the mobile device itself. And different phones, different hardware have different sensors embedded, but typically you can get pressure and sometimes temperature from Android and iPhone phones. So we thought that would be better than somebody just being subjective and giving their best guess. But we do have things that right now you can't measure by sensors in the phone. Those are things that we still thought were important, like sea state, visibility, and then general weather conditions. So those are more subjective fields that the user can add if he feels like it. But then finally, we're trying to access other authoritative weather station data. And we've interfaced Red Sky with the Kestrel handheld weather station made by Nielsen Kellerman, which provides a whole host of weather data, including, most importantly, wind data, wind speed and direction. It's done by a Bluetooth interface, and we're actually working with Nielsen Kellerman to interface with additional models that they produce. This is their most popular. And I just want to note that the weather source for the data is listed on the app, and it's also tagged to the data in the database. So as a NOAA person, if you're looking at this data, you can be selective for the sources of the data. If you don't want user subjective data, you just want sensor-based data, you can filter the database out and pull that out. So at this point, I'm going to give you a little tour of the app. I'm afraid this isn't a live tour, but it'll give you a feel for what it looks like. When you first log into the app, it brings you onto the map. Everything is map-based, and the maps have different fields. You can look at it from a Google map. If you're over land, there's nothing to prevent you from using this app over land, but we're trying to give it a marine flavor. So you can change the layers using the symbol in the upper left-hand part of the map between the bathymetry and the marine map to a Google Maps type layer. You can switch back and forth, but everything is based on the map. And you can see on the map here, this is off the coast of San Diego, looking at La Jolla. We've got some reports that were made off the coast. You also see in the lower left-hand side, there's a plus sign. The map acts as a dashboard for you. And you can expand the dashboard to show whatever sensors are connected to the phone, what they're measuring at present. So you can pull up what we call tiles that will list, say, temperature or humidity, and then we'll place them on the bottom of the map, and those will show real-time measurements as given by the phone or if you had a connected Bluetooth device. So the map always shows a dashboard at the bottom of what your sensors are telling you at any one time. Now, if you wanted to make a new report, you would click this upper right-hand corner plus sign, and that would bring up a blank report format for you. It brings the report up, and it fills in any of the, well, let me start at the top, I'm sorry. The first thing you can do is pick the weather state that you're experiencing. That's a subjective user selection from a predetermined list of basically symbols that will be put on the map where your report ends up. So you can see some of them on the left-hand side, the sun and the rain. So once you pick that, then the report is automatically populated with sensor data from sensors that are connected to the phone. And you can see in these fields, like temperature in the upper left, 74.77 degrees. That is coming from a Bluetooth connected device. It says BT device next to it. Down below, the pressure in kilopascals is shown. It's a phone-derived measurements that's coming from the iPhone itself. So those are typically populated by sensors that are connected to the phone. And then visibility, right now we have no way of measuring visibility with a sensor, so that's a user input. If you start typing in that box, it brings up a slider and you can just pick what you think the visibility is. And that goes with sea state. Right now, sea state has to be estimated. We do have some ideas for measuring sea state, but we haven't implemented them yet. But we thought it was important to include for boaters. And then the user gets to type in a description. This is where they can be creative. Remember, this is social media, so they can, you know, talk about what they're doing out there, like the fishing is good. Hopefully they will give us some input on weather, but they can type whatever they want in that field, the description field. Again, for social media, they can take a picture. They could take a picture of their boat, their dog. Maybe they can take a picture of, you know, the rain coming down. Again, hopefully it will be weather related, but people are the way they are. The report can get sent out over Twitter if you have a Twitter account, which is playing back to our technical point of contact's original intent. And then finally, to submit the report to the internet, you hit the submit button. So pretty simple. It's made to be done in a couple keystrokes with as much pre-populated as we can get. So then going back to the map, you have the ability to view reports made by other people, which is part of the public safety part. You can also filter the reports that you see by clicking on this button right here, which brings up a filtering menu, and you can filter on things like range from your current position, types of reports, age of the reports, even who is making the report. So, and that's something that we think is important because potentially the database could get pretty crowded. You can also see on the map that we are pulling in a National Buoy Data Sensor buoy reports, and those are filtered by your location as well. So that's a real-time poll that's updated periodically, pretty frequently, from the reports that are in the NOAA database or NBDC database. We thought those would be useful because they're pretty similar to the reports that the Red Sky people are making themselves. If you wanted to view an existing report on the map, you would click on it, and that would bring up this window. It would show the icon that the user selected, who reported it, that's the first line underneath the title, and how long ago it was made. You can see what weather conditions were reported. And then if you click the little eye in the upper right-hand corner, it will pull up the sources for those data. So you can see the wind was actually typed in by the user, but the pressure came from an iPhone 8. So that, again, is going back to trying to be a little more authoritative with our data sources. Another feature of the app is alerts. We thought that the users would, let's say you're going to be planning on taking the boat out later, but you're worried about, you know, the wind coming up and the sea state being a little heavy because you're bringing your mother-in-law and she gets sick if it's too rough out there. So you can set an alert within the app that will alert you if somebody reports conditions that exceed one of your criteria. And your alerts, you can define them using the settings button on the main page. It'll bring up this add alert page shown on the left. You can create a new alert, and then you can add one or multiple constraints to that alert defined any way you want. So for instance, this one, we called it the bad weather alert. And it says, I want to know any reports made within 20 miles of my position that have a temperature outside of 20 to 50 degrees Fahrenheit and have a wind speed within 20 to 100 meters per second. And you could continue to add as many constraints as you want. Once you've created that alert, the app will filter what's coming in, and it'll place little exclamation points on the map. One is shown here next to the word La Jolla on the right-hand side. And if you click on that, oh, well, I'm sorry, you don't even have to click on that. It'll also put a notification on your screen that says your alert went off and asks you if you'd like to see that. And if you wanted to see it, you'd click yes, and then it would pull up the report. Right now, we are not doing background notifications, which are notifications that would pop up if the app is not open. Going to my next screen. That's one of our planned additional capabilities, background alerting. And obviously, the user can select that or disable it if it's annoying, depending on what they want. So we're hoping to do that down the road. We're still also working on building the API for NOAA to query historical report data from the server. We're adding more handheld weather stations for Bluetooth connectivity for additional measurements. We're also adding additional measurements like tiles. As phones become more sophisticated, they can measure more things. So we want to add those. Right now, we report temperature, pressure, dew point, wind speed and direction, and relative humidity from sensor measurements. We want to add an ability for the user to select his choice of units. If he wants knots instead of meters per second for winds, he can just select that in his preferences. And we also are talking about adding the option for the phone to periodically report automatically without any, so you don't have to make a manual report. The phone would just compose and send out a report every 15 minutes, which would be great for NOAA. It would be great for everybody else, but it might drain your phone's battery. So there's a plus and minus with that. But we think that might be a really nice feature to get a consistent database going. So the point of every SBIR effort is to spin the technology off into a successful commercialization effort. You know, we're not only just trying to innovate, but we're trying to make the technology be sustainable and have a life of its own and lead to other things for both the company and for the original organization that sponsored it. So I wanted to talk a little bit about the efforts we've been making to date to commercialize MARAP. That's kind of my job as the principal investigator in this effort. We've been working very hard to try to identify who are the data consumers within NOAA. The app was originally designed to inform the forecasters, but it also had that little hook saying the data could be made available for people running models at NOAA to do environmental predictions. And we're working hard to try to figure out who those people are so that we can get their feedback on, are we providing data that they want, or do they want something different, or whatever, you know, who's going to be using this API. We're also looking for potential sponsors within NOAA. It's really obvious that this thing is tailored towards NOAA, and so we're looking to see if there's somebody within NOAA that would like to pick up and sustain the program. I mean, apps aren't terribly expensive to keep going, but they do cost something. And we have that experience from the search and rescue app that we've been running for the last 10 years. So where have we been looking within NOAA? Well, NOAA is a very interesting organization, and it's a little difficult to navigate if you're new, but we thought the obvious choice was the observations office, because they do things like the Volunteer Observation Program, which is trained volunteers making periodic weather reports. And they support the National Buoy Data Center, which is, you know, hardware placed in the ocean to make periodic data reports. So, you know, what you could argue that potentially crowdsourcing weather through an app like Red Sky could possibly replace the volunteer observation program down the road and could provide a quote free source of weather data, or maybe less expensive. I don't know. So we've been trying to talk to people in the observations office to suggest this and see if they'd be interested in these data. One organization that we recently stumbled upon that we've been having very good discussions with is the Integrated Ocean Observing System, the IOOS, and their regional partners such as the Southern California and Gulf Coast IOOS organizations. They are interested in citizen science and crowdsourcing. And one comment that somebody made that we were talking to was that you just cannot afford to put the amount of hardware that you need in the ocean to sample enough spatially and temporally. So you've got to resort to something like crowdsourcing to get the data that you want, for the uniformity of data that you want. So we're hoping that we might have found our niche within the IOOS organization. We're also trying to talk to the National Center for Environmental Prediction, where they run these models. We realize there's some quality control issues there, but we'd like to find out if this data could be made of use to them. And we've also been talking to other people who have developed apps for NOAA along the lines of the citizen science slant, that NOAA seems pretty interested in doing that these days and listing citizen scientists. One very successful app is MPing, and another one is CrowdMag. MPing looks at, it gives feedback for environmental conditions with storms and radar, and CrowdMag will crowdsource magnetic variance in locations and is trying to map magnetic variance. We're also looking at different efforts for web portals to display data, like visitbeaches.org, which talks about surf and red tide conditions. Other web portals that NOAA is sponsoring that kind of take data and make it available to the general public for public safety. We think our data could fit into that. Outside of NOAA, we've also been exploring subscription models for premium app features. This is typically what app developers do to make money, is they entice you in with something free and then they offer premium features and supposedly pay the bills that way. And then we realize that if we get the ball rolling and this becomes it goes viral and people start using it a lot, we'll have a lot of data, and data is currency. And we've talked about potentially licensing data to organizations like the Weather Underground, which started as a crowdsourcing kind of organization, or other potential organizations that would be interested in our data. So that's difficult. Metron isn't a company that does a lot of selling of things. We do more consulting and services things. So we've been working as hard as we can to try to understand the market and how we stand out in that market. And then finally, we've been talking to hardware providers such as Nielsen Kellerman, the company that makes the Kestrel, talking about doing partnerships with them, maybe bundling our software with their handheld weather stations and taking some sort of a cut from their sale. Right now, it's more a discussion of promotion through them as opposed to being paid by them, because we don't have a working app yet. We don't have users yet. We have to show our worth before we can actually come to the table and potentially talk about more rigorous partnerships. And with that, that's all that I have. I have my contact information up there if anybody's interested in contacting me. And I want to note that we are looking at setting up redsky.com as a simple interface to explain and provide documentation, explain our concept, but we haven't set that up yet. So if you try to go there, you don't get anywhere. But it looks like Red Sky is available, and we will be there and active and live within the next month. So Vince, Derek, that's all that I have.
Thank you so much, Colleen. I think it's Q&A time at this point, right? So I guess we can start by Q&A. People here on any questions from the audience here?
Yeah, my name's Phil Hall. I didn't know the iPhone even had a sensor for pressure. That's interesting. Do you know why they put it in there? For what purpose?
Did you hear that, Colleen?
Yeah, I did. The iPhone measures pressure, I think, not even temperature. And the Android does as well. And why they put it in there? No, I'm not sure.
And do you guys, did you have to go through any calibration to see how good the pressure sensor is in the mobile phones? Is there like a difference?
No, that's a very interesting question, and I don't even remember if we compared the Samsung that we're using for development and the iPhone 8 that we have. That would be an interesting comparison. No, we certainly didn't calibrate, and I don't think I guess we could, I guess we could adjust it software-wise. I'm not really sure what variation there would be phone to phone. That's very interesting. I'm not sure how we would quite calibrate it because each version of the phone could potentially be different, right?
Yeah, I mean, I did it. I guess it goes back to my original question. What was the purpose? But certainly, there's organizations in NOAA that would be able to help in that aspect. We've got pressure calibration facilities and things like that. So.
Yeah, I mean, if we knew that a certain model of the phone was always off by 10%, we could adjust the reading in the software, but the question is, are they consistently off by 10%? And is it a linear, or is it a constant, error? I don't know. There's a lot of questions there. That's a good question. We could look into that.
Thank you. Anybody else? Yes.
So, Colleen, this is the other Philip sitting in the room at the library, which gets confusing when Phil and I are both in the same meeting. But you mentioned very early on the private pilot, the pilot reports, and your work as a private aviator. And I'm wondering, given the number of general aviation fields, particularly pilot-controlled small airspaces, and low-altitude general aviation flying that we see in the coastal zone and in the near shore, if you all have had any thoughts about crosswalking what you're doing with the general aviation community, either to drive data to them or to bring data in from them as a way of expanding your reach and expanding your data set.
Oh, I have thought a lot about that as a private pilot. And there is really nothing to prevent people from making a report from the air, except it wouldn't be able to give your altitude, or it wouldn't be able to give altitude, although you probably could put it in comments. And obviously our interface isn't designed to show that it's a pilot report vice a maritime or surface report. But as a pilot, I can tell you that the phone works just fine in the air up to maybe about 10 or 12,000 feet, and then you start to lose it. But anybody in the lower altitudes is where a lot of the weather is too, right? And where a lot of the pilots are, the pilots that don't have professional weather. So it would be a great portal for pilot reports, and I would love to make a slight modification and then introduce that as well.
Great. Anybody else?
Hi, Colleen. This is Amy Fritz coming from the Weather Service. I know you're getting started with notifications, and I know as notifications go, some are great. A few could be useful, but there comes a point in which you get too many. And so I was wondering what your plans are for, say, large marine events, like, since this is coming out of Seattle, the first one I thought of was Seafair. And, when you've got a lot of people out on the water, they're all excited, and there's that one thunderstorm that pops out, and you have everybody decide to take pictures and update, and they want to be the first one to post it. Have you thought about how to filter or thin out some of those reports so that you don't overwhelm the phones or the users?
Well, there's this button that's the on-off button, and I think that's really
I wasn't sure if you had send maybe one a minute or one every 5 minutes rather than suddenly a lightning bolt struck out over the water, or a funnel cloud appeared, and you've got all these, meteorologist enthusiasts, say at the beach or something. I remember seeing a funnel cloud out at the Outer Banks, and you would not believe how much of a crowd it drew. You think people would, take cover, but no, people wanted to get closer to it.
Yeah,
so I just wasn't sure if you guys had thought about that and had kind of some kind of filter or something in place so that
yeah,
people don't get overwhelmed.
People are. They're such show-offs. They're all storm chasers. So the best thing we could do is turn off the notifications. You can collapse the notifications down to a tight circle. I don't even think that we have a way of saying only show X notifications, but we could probably implement that fairly easily. Just show a maximum of 5 or something like that. That's we really hadn't thought that far because we haven't actually seen it in use yet.
It would be one of my recommendations to consider. Things that can become popular can suddenly become too popular. So,
I know.
It's a suggestion from a potential user.
Yeah, and I'm as annoyed as anybody about notifications, and I typically suppress most of my notifications. So I hear you.
All right, thank you, Colleen.
You're welcome. Thank you.
Okay, we have, Colleen, we have a number of questions online. Some are more technical than others. I'm just going to start off. One of our online users wanted to know, how does wind speed get calculated from vessels that are underway?
Oh, that's a really good question. I think that it's not going to be correct if the vessel is moving. That's something we hadn't thought about. We thought about wind speed being taken from, say, a fishing vessel or something that's stationary. But if it is underway, we're going to have to caution people that that's not a correct measurement if the vessel is moving. Very good point.
Okay, thank you. Second question, does this app, or will it receive a NOAA weather alert?
We don't currently have that, but that is, it's like, we were building the app and we thought, oh, we should pull in this buoy data. And if there are other things that we could pull in that would be of use to these people that, wouldn't overwhelm them, then I definitely think that we would consider that. That would be appropriate to show.
Okay, and to follow up with that, will there be a capability in case a person is in some sort of an emergency that they could get assistance, 911 or something like that?
I think my opinion would be that they should dial 911 on their phone by using the app. So we didn't plan to put any kind of emergency assistance into the app. We figured they had marine radio, and if they're holding a cell phone, they could make a call, right?
Okay, another question. Is it planned to add sea surface temperature as a default variable?
We did look at sea surface temperature specifically because we thought that many boats measure it. If they have inboard motors, they typically will measure the temperature of the water going through the, or they have access to that. And so that is one of the parameters that we were thinking about adding, yes.
Okay. Does Metron plan to add weather observations from NOAA, NOS, ports, mesonets, and NOAA NWLON weather stations?
NWLON. We did not plan to do that. I actually have to admit ignorance, and I could look into it. And if that person that posed the question would like to email me, I would love to hear more about that. We would consider it.
We do have a question about remote users. Is there any, has anyone explored connections to satellite phones to allow for users along remote coasts, for example, Alaska, being able to submit observations and view up-to-date data observations in near real time while at sea?
Well, I'm not really sure how we would modify the app to do that. I don't normally use a sat phone, but if it in some way can act as a modem to connect your cell phone, then you could, in theory, send your reports over the satellite connection. No, we hadn't considered that, but obviously if they're that remote, there are places where we would love to have, more data. They are also places that potentially people don't operate in as well. So the principle is to kind of get reports where you have a lot of people, because those people care about, the conditions, but it would still be of value, especially to NOAA, to have remote reports. I don't know how we would modify the app so it would be, so it would work over the satellite sat phone network. I guess I don't know how sat phones work that well.
Okay, no, thank you. Jumping back to how people put information into this app, with the subjectiveness of wave height and visibility, depending on a person, is there going to be aids to assist the users to getting a correct or closer to accurate reading?
That's very interesting, like a little primer on how to measure visibility or wave height, or how to estimate it. We hadn't thought about that. Going back to the sea state, we're pretty close to having an algorithm for estimating sea state using the gyroscopes inside the phone, which, you can do a whole bunch of cool things with iPhones, right? You see people moving their iPhones around and measuring things. And we had something developed, but we shelved it because we were trying to get a minimum viable product out, an end-to-end product, and it was taking a little bit longer. But we think that's doable, and that might be a way to give you a more authoritative measurement of sea state. Visibility is tough, and I'm not sure how we would give guidance for measuring visibility. And so I think that measurement coming into the database is always going to be a little bit questionable or iffy by NOAA standards, by quality control standards. But if somebody has a suggestion, even like an info page that you could pull up on the phone that would give tips for measuring visibility, that would be something that could be easily added.
A few more questions. How do you plan on doing data quality control and flagging? Lessons from WeatherBug, I'm not sure if you're familiar with that.
Yeah, we're familiar with WeatherBug, and we've also been talking to the IUS people about the plentitude of quality control requirements before data goes into certain databases. So we hadn't initially thought about this, but we've been becoming educated on the QC that data has to undergo. We were told that at the very least, the data needs to be screened by a human before it gets ingested by models. And that sounds like very labor intensive, and we're a bit concerned about that. We certainly don't have the manpower for the potential amount of data that we're going to be generating. We can do things, I think we actually do things to check for glaring errors, like too many digits or data outside certain ranges. But in terms of, saying that just doesn't sound right, or we had also ideas about vetting the data, comparing it to peers, like if there are 5 reports in a general area, and one of them is really an outlier, we might throw it away. Whereas if other reports are supported or strengthened by similar support reports, then we would, put more confidence into that. Kind of like how many thumbs up you get on your Facebook post, vetting by social media. I don't know how that stands up to NOAA standards for QC, but, and I understand there's lots of publications on QC procedures, but we have been giving some thought to what we could do within reason, given that this is crowdsourced weather data.
Okay, thank you. We have, I'm going to say 3 more questions. Are measurements from inland waterways of interest for this?
Absolutely. We were talking about the Chesapeake Bay and the St. Lawrence Seaway, and then the Great Lakes as being, great examples of places where, very localized, specific type weather that would be useful to get data from these. And we'd like to publicize it specifically for areas like that. And also the Seattle Bay area is another big area that we were looking at. So most definitely.
Okay, thank you. Back to the app and how it displays, are there any plans to add the Weather Service's weather radar reflectivity images as an overlay layer?
No, we didn't have any plans for that. I think an overlay would be easy to just toggle on and off, and it would be really nice. I have no idea how hard that would be to do, or if that data is available and then we could just add it. That could be a premium feature like I was talking about earlier. So I'll certainly put it on the list.
Awesome. Last one we have from one of our online people, Ken Johnson. He's saying most sailboats have weather instruments. Would it be possible to work with sailboat makers to access the data coming from their instruments? Yes, absolutely. That falls into the category of handheld sensors. I figured anything on the boat is a candidate for a sensor measurement. The problematic thing is that we want it automatic. We want it Bluetoothed. And so if you put that requirement on the host of weather stations out there, it kind of narrows it down pretty quickly. Some of them are Wi-Fi, like the weather station that I have installed at my house for weather underground connectivity. But a lot of stuff on boats isn't Bluetooth, and we'd have to figure out if we could connect by Wi-Fi. It would be an extra step that would be a little bit complicated. Certainly the person could read the data from the weather station and type it into the app. We could provide a field for that. As for partnering with boat manufacturers, that kind of falls in the lines of the, the technology partnership that we're considering with Nielsen Kellerman. And we would probably try Nielsen Kellerman first and see how well that was received, and then maybe start approaching manufacturers that are installing these things permanently in boats and see if that would be, if it would be of interest to partner with them. Okay, great. And one final question. This is available nationwide in terms of data collection, correct? Absolutely.
Yeah, I just want to emphasize again, it's targeted to the maritime audience, but that's more for marketing because that's a niche. I mean, there's a lot of weather. If you just type weather app into the app stores, you get reams of, offerings. But we didn't see anything for the maritime area. So we decided to focus on that, but there's nothing to prevent you from making reports out of your house, overseas, anywhere around the world for that matter, in the air, in your car. So it can certainly be used anywhere you want.
So I think that's all the questions we have. I don't have any questions myself, and we're almost done for the hour. But I do want to add a couple of things for the, especially for the NOAA folks on the call. Colleen and the folks at Metron currently have an SBIR Phase II with us. As she had mentioned earlier, the technical point of contact, Jay and Logan, those are the NOAA folks that are kind of intimately involved in helping her guide her through this project. Because we are currently in a contract for this Phase II, I want to make sure that we're careful not to kind of direct her or Colleen so that that you're not adding any new features that can potentially add more cost to you and I guess make a mess out of the contract that you currently have. So, please, Colleen, I want you to work directly with the technical point of contact that you have, and then kind of work within those areas, and obviously address some of the concerns that some of the NOAA folks here have pointed out. They're great additions to have. They're great to have, but we want to make sure we're within contract. So, and also for the other folks that are interested in perhaps providing extra funds for further R&D, that would qualify as a phase 3. If any of you NOAA folks are interested in doing that, are very interested in this technology, you know, you can contact me or Colleen and we can make that happen. So, and I'm going to pass that to you to close out.
Okay, yeah, so this is Derek. Just to wrap up, thank you all for joining us again for the Innovators Series. Please join us next month. We're going to be talking with some of our folks out of Alaska about a device that was developed up there called the iGauge. It's a river height measurement gauge that has been successfully commercialized. So we're going to talk about that process and let you know a little bit more about the device itself and the company. So we hope to see you virtually next month.
Okay. Thank you, everyone. Thank you, Colleen, and I'm going to close this out.
Thank you.
Thank you. Bye-bye.